Hello. So today we're going to talk about topics 5.3 and 5.4. We're going to identify when functions are increasing, decreasing, and then we're going to use that information to find maximums and minimums. So we kind of already know what an increasing function looks like or a decreasing function looks like. Constant would be when it's flat. However, we want to pair that idea with this concept of the derivative. So if you have a increasing function, okay, then you know that the derivative has to be greater than zero. So ultimately, for a lot of the functions today, we're going to take derivatives. We're going to figure out where that is greater than zero would be increasing, and where that's less than zero would be decreasing. Again, the derivative finds the slope. So if the slope is positive, we know that it's increasing at that point. If we know that the slope is negative, then we know it's decreasing at that point. So just to start basic, I have a graph here of f prime. Now, it's very important whenever I give you a graph, you always need to take a look at what that graph is of. So we know, get my pen working here. Okay. Yes. There we go. Okay. So we know that this is f prime of x. So this is a graph of the slopes. Okay. So if you take a look at this, from 0 all the way to 2, right? This section of my graph is positive. This section of my graph on the right is also positive. And then we have two sections in which we have negative values for our derivative. Now, again, this is not the graph of the original function. This is the graph of the derivative. So based off of this information, okay, I can say that f of x, and actually I'm going to be very specific here with my writing. F of x, the original function, is increasing from 0 to 2 and from 4 to infinity. Now, we also know f of x is decreasing from negative infinity to 0 and from 2 to 4 because it's below the x-axis. And again, those would be negative slopes. Okay, so the first idea is understanding the concept of how the derivative tells us if the original function is increasing or decreasing. Okay, so let's go to now let's do a little algebraic. So I give you the same idea. I want to know the intervals of where it's increasing or decreasing. So the first thing that we're going to do here is we are going to take the derivative and we're going to find our critical points, where the derivative is 0 or where the derivative is undefined. So I want to start. Help if my pen was writing. There we go. Okay. So f prime of x, I like to label everything, is going to be a 3x squared minus 3x. Because if I drop the 2 down, if I do a little power rule there, 2 times 3 halves is just a negative 3. Okay, and I want to find my critical points, so I want to know where that is equal to 0. Okay, so if I solve this, now I'm going to do a little factoring. That gives me an x minus 1 if I factor out a 3x. So I know my critical points are going to be at x equals 0 and at x equals 1. Okay, so here's what I do next. I am going to make a number line. I'm going to label this number line f prime. And I'm going to put those critical points on my number line. Okay, now what I want to do is I want to substitute those critical points into my derivative. So if I want to find, let's say I want to point somewhere between negative infinity and 0. So I want to know f prime of negative 1, right? I want to know what that's going to be. So I'm going to have 3 times a negative 1, and then a negative 1 minus 1. Now, I don't really care if it's value. I just want to know, is it going to be increasing or decreasing over that interval? Okay, so if you do this, I'm going to get 3 times a negative 1 times a negative 2, and ultimately that is going to be a positive 6. And I don't really care that it's 6. I care that it's positive. So I know over this interval, it's positive. Now, I'm going to test between the next interval, between 0 and 1. So if I put in, let's say, 0.5, I have 3 times 0.5 times 0.5 minus 1. And ultimately, I'm going to get a 3 times a 0.5 times a negative 0.5, which, if you work that out, again, I don't really care what the value is. I know that it's going to be negative. Okay. And then last but not least, f prime of, let's say, 2, something bigger than 1. 3 times 2, 2 minus 1 gives me 3 times 2 times 1, which would be a positive value. So I know it's going to go positive here. So with what we have on our screen, we can draw some conclusions. I know that my function is going to increase from negative infinity to 0 and from 1 to infinity. Now, I also know it's going to decrease from 0 to 1 because, again, that's where my derivative was negative. So this is the big idea here. We want to be able to find the intervals of increase and decrease. Okay. So I kind of put together some guidelines here. So if I give you a function, right, I want to find the critical numbers. I want to, after you find those critical points, I'm going to I'm going to use test values to figure out what the sign is between each of interval, and then I can determine whether or not it's increasing or decreasing for that value. Okay? All right. So now we have a second piece. It's called the first derivative test. So I want to talk about, we're going to still find increasing, decreasing, but we want to use it to kind of identify where the maximums and minimums of our function are. So if we change, if the derivative goes from negative to positive, so if it goes decreasing to increasing, okay, so just an idea of what that looks like on your screen. So for this first example here, if it goes decreasing to increasing, right, then I know that my function is going to have a minimum. Now, likewise, if your function goes from increasing to decreasing, again, your function is going to have a maximum. If there's no sign change, then you don't have a relative min or a relative max. So here's some pictures here. So again, you can see here, the derivative is less than 0, it's decreasing. And then the derivative is greater than 0, it's increasing, right? That's why we have a minimum. So it went from negative to positive. And I should be more specific. The derivative went from negative to positive. Now, if it flip-flops, if you go from positive to negative, then you're going to have a maximum. Okay? But here in this third example, this third picture, we have it's positive and it's still positive. So there is no extrema. In this case, it's negative and then it's negative. There is no extrema. Okay. So just some little vocabulary. Extrema refers to all of the maximums and minimums. A minima is just plural. Maxima are just plural of those terms. Okay, so let's try to put this into practice. I want all of the relative extrema. I want all of the maxes and mins for this function between 0 and 2 pi. Okay, so I need to first start by taking the derivative and finding those critical points. So the derivative of 1/2 x is just a 1/2, and the derivative of sine is a cosine, and it was minus, so it's still negative. Okay, so now I want to set this equal to 0. I'm going to solve it, so I have a negative 1/2 equals a negative cosine of x, and I can say cosine is equal to 1/2. Now, I have to think of my unit circle. For what values would cosine be 1/2, right? Between 0 and 2 pi. So if I think for a second, that's going to be where x is going to be at pi over 3 and 2 pi. Oh, I think it's just pi over 3, because 2 pi over 3 cosine would actually be negative. So at pi over 3 and at in the fourth quadrant, I'm going to say that's going to be 5 pi over 3. Okay, so these are my two angles for which that happens. Now, what I'm going to do is I'm going to make that number line. All right, and I want to test around it. Now, we're going from 0 to 2 pi, so I don't really want to go outside of that range. So I want to use a value somewhere between 0 and 2 pi. And again, I want to plug it into the derivative. Okay, so if I want f prime of, let's say, something between 0 and pi over 3, let's say pi over 4, right? That would be a 1/2 minus cosine of pi over 4, which would be a 1/2 minus a square root 2 over 2. Now, I need my calculator here a little bit, but I'm pretty sure this will end up being negative. Okay. Then I want to check a point between pi over 3 and 5 pi over 3. So I'm going to use, let's say, pi. Sounds like a good one. So I have a 1/2 minus cosine of pi, which would be a 1/2 minus a negative 1, which is definitely positive. So I know it goes negative to positive. And then I have f prime of something between 5 pi over 3 and 2 pi. So we're going to do, let's say, 5 pi over 4 would be a 1/2 minus cosine of 5 pi over 4, which actually I believe will give us the same thing as the first part that we did. And we know that that's going to be negative. Okay, so my function decreases from 0 to pi over 3 and then increases. Now, because it changed signs, because the derivative changed signs at pi over 3, and it went from decreasing to increasing, we know this has to be a minimum. I know this point at 5 pi over 3 has to be a maximum. Right? That's the idea. So I'm going to have a relative min at x equals pi over 3, and I'm going to have a relative max when x is a 5 pi over 3. Okay? So let's do it one more time. Same idea. Okay? So I give you a new function. So we're going to find the derivative of this function. All right? So I want f prime would be a 2/3 x squared minus 4 to now the negative 1/3 times 2x. Okay, which, if I do this, I get a 4x over 3 times x squared minus 4 to the 1/3 power. Okay, so I want to find my critical points. Now my critical points are going to be where this is 0 or undefined. So my critical points, I'm going to separate into two categories here. Okay, so the first category is where f prime of x is 0, which means I want to know where 4x all over 3 times x squared minus 4 to the 1/3 is going to be 0. Now, if you have a fraction equal to 0, ultimately that just means the numerator has to be 0. So the 4x has to be 0, or in this case, we know 4 times 0, so x has to be 0. That is one of my critical points. Now, the other critical point, this has another one, is going to be where f prime of x is undefined. And that comes, your derivative is going to be undefined when the denominator is 0, right? An undefined fraction is when I have some sort of constant over 0. So I'm going to take the denominator, the 3 times x squared minus 4 to the 1/3 power. I'm going to set that equal to 0. Now, if you divide the 3, doesn't really change too much. If you then, to get rid of the 1/3 power, you can cube both sides, but that doesn't really change too much. I just have an x squared minus 4. 0 cubed is still 0. I can factor that, x plus 2x minus 2, and I know x has to equal 2 and negative 2. So I have 3 critical points. Okay, so now I want to test around those critical points. So I'm going to make my number line. Helps me organize my information. I always like to label it f prime of x. And I'm going to put negative 2, 0, and 2 on that number line. And I want to test around those points. So let's say f prime of negative 3. So I'm going to plug negative 3 into the derivative. So I have a 4 times negative 3. I have a negative 3 squared minus 4 to the 1/3 power. Now again, I don't really care about the value. I care about what the sign is. Now the top will definitely be negative. The bottom will also be negative. So if I have a negative over a negative, that is a positive answer. If I have f prime, I'm going to pick a number between negative 2 and 0. Negative 1 seems like a good one. 4 times a negative 1 all over 3 times a negative 1 squared. Oh, you know what? This would have been positive. Sorry about that, guys. The denominator would have been positive on the first one, which would have given me a negative or decreasing slope. Okay? And I realize that because I think we're going to have a little sign change here. This is 4 times a negative 1 is a negative 4, and this would be minus 4 to the 1/3 power. That would be negative. There we go. That looks better. So if I have a negative over negative, that is a positive. I can do the same thing at 1. So 4 times 1 all over 3 times a 1 squared minus 4 to the 1/3, which would give me a positive over a negative, which would be negative. And then last but not least, f prime of something bigger than 2, let's say 3. You plug that in. I think I'm going to get, I ran out of room here a little bit, but I'm pretty sure we're going to get a positive value. Okay, so based on this, I know negative 2 will be a relative min. 0 will be a max because it goes from positive to negative, and then it goes back negative to positive, so I have a second relative min. So I have relative mins at x equals -2 and x equals 2, and I have a relative max at x equals 0. Okay, that's the idea. So we're taking the derivative, finding the critical points, and then we're going to test around those critical points, all right, to figure out is it increasing, decreasing, and then we can use that, okay, to find our maxes and mins. All right, last one. So I want to take the derivative, and we can do a quotient rule here. So I'm going to say low d high minus high d low all over the bottom squared. And I'm going to try to make this look a little nicer. So I have a 4x to the 5th minus a 2x to the 5th minus 2x all over x to the 4th. I can combine like terms. Gives me a 2x to the 5th minus 2x all over x to the 4th. I am going to reduce that a little bit. You can factor out an x from the top. Actually, well, the 2 doesn't really help me. 2x to the 4th minus 2 all over x to the 4th, and then I can cancel one of those out. So I have a 2x to the 4th minus 2 all over x to the 3rd. So that's my derivative, right? So now I want to find the critical points. But critical points can be where it's 0 or undefined. So I want to know where f prime of x is equal to 0, which means I want to know where 2x to the 4th minus 2 is equal to 0. Because it's a fraction, I just want to know where the numerator is equal to 0. And if you add the 2, divide the 2, I get to the x 4th equals 1. And if you take the 4th root of that, you get a plus or minus 1. Now, I also want to know where it's undefined. And that's going to be where x cubed is 0. In this case, where x equals 0. However, I am not going to include this 0. The reason being, it is a critical point, it is where it's undefined, but it doesn't actually appear on my graph. There is an asymptote, okay, on the original function where x is 0. That point isn't actually part of my function. Therefore, it can't be a max or a min. Now, if you don't see that, that's okay. It would come out when you try to find the maximum and minimum anyway, right? But what I am going to do is on my number line, I'm going to put a -1. I'm still putting the 0 because there's an asymptote there, and a +1. And I'm going to test around those points. Now, in the derivative, again, I always check in the derivative. So I'm going to do f prime of -2. So I have 2 times a -2 to the 4th minus 2 all over a -2 cubed. So I'm going to get definitely positive on top. -2 cubed is negative, so that would be a negative answer. Now, f prime of, let's say, a number between -1 and 0 would be a -0.5. So 2 times a -0.5 squared, or sorry, to the 4th minus 2 all over -2, I'm sorry, -0.5, excuse me there. To the 3rd. So I'm going to get a negative over a negative, which ultimately gives me a positive. I know it's increasing over that interval. So now we're going to do a +0.5. So 2 times 0.5 to the fourth minus 2. That's still going to be negative on top. And 0.5 cubed will be positive on bottom. That gives me a negative fraction. And last but not least, I want to know at, let's say, positive 2. And that would give me a positive over a positive, which is a positive. So based off of the information that I've found, I have a minimum here. I have a minimum here. And you would think that I have a max. But again, at 0, there's an asymptote at 0. So therefore, you can't have a maximum at that point. Now, I said before, you might find that when you actually try to find the mins and maxes. And the reason I say that is because if I actually plug in -1 into my function, you can find the location of that maximum or that maximum value. I'm sorry, in this case, minimum. So I can also plug in 1 and find that minimum value. If you plug in 0, it's going to be undefined. You know that that can't be a max or a min. Okay. Now, on this side, I have 3 pictures. Okay. So if you notice that these would be the points, these 3 pictures represent the 3 functions that we just did. Okay. And if you look at this last one, do you see how we have 2 minimums and we don't have any maximum? The reason is because that maximum we found is an asymptote, and that does not ever join together. So this is just the graphical representation to show you. So for example, 1 at pi thirds and at 5 pi thirds, we had a min and a max. So you can see here, pi thirds and 5 pi thirds. And then for the next one, okay, at -2 and 2, okay, so for B, -2 and 2 were our mins, and then I have a max at 0, and then -1 and 1 are our minimums, okay? So this is how we find relative extrema. We're going to take the derivative, find the critical points, test around those critical points, and then based off of those test results, that tells us what type of extrema we would have. Remember, extrema always occur at those critical points, so it's imperative that you can take the derivative and you can set it equal to 0 and solve it, okay?